Hello, everyone, and welcome to this Observability Tech Talk edition, where we're going to be talking about how you can build a self-service and scalable observability practice with Splunk. I'm very glad here to be with you, and I'm today with Corey. Corey, do you want to introduce yourselves to the people here?
Yes, hello, and thank you for having me, Joanna. My name is Corey. I'm part of our observability strategist team. I work really closely with our product engineering, our customers, and the industry to help all things best practices, observability, and use cases and problems and everything really observability within Splunk. I'm a big foodie. I'm a big jazz fan. I live in Melbourne, Australia. So of course, I'm a big coffee snob, and I'm a horrendous overuser of memes. Spoiler alert.
Awesome. And I'm Joanna. I'm a senior product marketing manager in the observability team. I do some ballet. I play the piano. I don't do any jazz though, Corey. Sorry to tell you that. And I'm a big TV show nerd, so also a little bit of a spoiler alert here. All right, let's jump ahead. Now, before we get into the content, wanted to bring people's attention to our agenda. So we're first going to be talking about why you should care about building a scalable and self-service practice for observability. Then we're going to go over the Splunk enterprise observability features, including OpenTelemetry, RBAC, observability-as-code, and more. Then we're going to show you how you can start implementing these features today, and then we'll leave some time at the end for Q&A. Now, if you do have some question during the presentation, feel free to ask them in the chat, and we'll try to answer them as we go through the presentation. All right, so why should you care about a scalable and self-service practice for observability? Now, in this ideal world, right, you have one single platform where essentially you would power all the developer teams across multiple use cases, processes, right? That one internal developer platform would help every developer team, and they would rely on that one single and extensible platform, which would allow them to easily collaborate and really get what they need without any compromise. And on the other hand, the platform engineer, right, who would kind of manage that internal developer platform, would have all the visibility they need to get more control over the data usage and role management, and also get more visibility into costs so that they can get more control over overages. But in reality, things are a little bit more complicated, right? Most organizations, according to our last report, deal with over an average of 23 different observability tools. This is a lot of different tools. And usually all of these tools, they're built for team-specific needs. So they have their own standards, their own processes, which eventually leads to developer teams operating in silos, and that also leads to longer war rooms. But not only that, right? Because those tools are very siloed, there's a lack of shared visibility, which eventually will prevent platform engineers to effectively monitor and control data usage, which also would eventually lead to those high costs of your monitoring and really not allow your organization to scale effectively. Now, this leads to two main problems, right? There's an engineering problem, there's a business problem, and then there's a customer problem. On the customer side, right, those tools sprawl and the fact that they're all separate, that leads to a more broken CI/CD pipeline, which will hinder that innovation pace and eventually affect those digital experiences. On the developer side, right, there's a more cumbersome workflow which eventually impacts the developer experience, and which has to deal with toil and basically lower productivity. And then finally, that lack of visibility that I mentioned before on your observability telemetry caused by this distributed observability practice will lead to those high and unpredictable costs. In other words, if you're somebody more visual like me, if you don't have a standardized observability practice, your engineering team might end up looking more like this, which is a community scene. So if you haven't seen that episode or this show, I highly recommend you do. All right, so what's the solution? Well, you might have guessed it by now. It's building a self-service model with a more mature observability platform. Okay, so what does that mean? Essentially, when you have a self-service observability practice, you have different benefits that are laid out here. The first one being that you have higher productivity, right? Because you're able to have you're able to benefit from faster CI/CD pipelines, which was mentioned before, so less toil, and better. So you're able to provide better and more competitive digital experiences. Now, the other advantage of a self-service operate observability model is that you have less toil because you're operating on a more code mode, and so that also helps you be less error prone. The other benefit is that you are somewhat a subject matter expert where and when it matters, right? You don't need to rely on essential tool teams anymore. You can sort of build and do your own stuff on your own without having to ask somebody else to do it for you. The other benefit is that you're dealing with more agile processes and workflows. Now, let's say you have to tweak an alert, right? Usually you would need somebody else to do it, but now you can kind of do your own discrete tasks and not having to depend on somebody else who usually has a huge backlog. And so now you can basically do those little things like tweaking an alert on your own and eventually deal with more agile and nimble processes.
We all know the frustration of submitting a threshold change and it taking 2 weeks to get implemented. So I'm right with you there.
Exactly. The other advantage of the self-service practice is that you get access to a more templated and patterned ways of working. What does that mean? Now, you don't need to start everything from scratch each time you need to put, some dashboard together or any sort of asset. Now you get access to more defaults, and you can also reuse stuff from other teams for your specific use case. So you basically can optimize and accelerate your ways of working. And then finally, you have to deal with fewer bottlenecks from onboarding and insights. Everything is much more repeatable in a self-service observability model. You're able to get access to more insights from other teams. There's essentially a better knowledge transfer of analytics because of that templated ways of working and because everything is much more agile. You don't need to raise a ticket to get something done either, which eventually also reduces these bottlenecks that you usually deal with in a distributed observability model. All right, so if this hasn't convinced you yet, you can just listen to the IT engineering leaders who have consistently said that a mature observability practice really leads to amazing results. The first one being that they drive more developer innovation and speed. They also see that a faster ways of finding and fixing issues. And then finally, they're also able to share data and resources across their security and observability teams more often with a mature observability practice. Now, if you're wondering how Splunk can help you achieve those results and get to that self-service observability model, Corey will now describe to you all the different features that Splunk provides and help you get to that ideal observability state.
Thanks, Joanna. That was some great insights. And this report, by the way, has a lot of cool findings in there. And we'll have a link to it towards the end of the deck as well. So please go and have a look. There's a lot in there, and there's also region-based insights too. So for all my fellow APAC friends, there's some specific insights to Asia Pacific and all the folks in EMEA and Europe. It's done a great breakdown of specific to us and your region. Okay, so the Splunk way. How can we help you towards building this great model, being self-service and really agile? Well, at a high level view, all the parts of the puzzle, this high level architecture, the things that kind of make up what we're talking about is, of course, your Splunk Enterprise, your Splunk Cloud, and your Splunk Observability Cloud platform. Your data and app environments, your digital environment, really wherever it is, whether it's on-premise, cloud, SaaS application, doesn't matter, right? So wherever your data is, those are key. And then in this instance, we're also hooking into your code repository, your orchestration automation, your CI/CD, and your authentication and access platform. So these are really all the key pieces of the puzzle. All right. So the first capability, the first feature that we're going to be discussing here is OpenTelemetry and how that fits into the picture. Now, I know that not everyone is familiar with OpenTelemetry. It's also short for OTel. So if you hear me saying OTel, know that that is just OpenTelemetry shortened. So what is OpenTelemetry? Uh, this has been a problem, how we collect and standardize data, do it in a way that's consistent so that, every team within the business, let alone multiple businesses, we're all talking really the same language when we collect data and we're following the same processes. So it's been a big problem in the industry. At one stage, there was about 27 or so different open source projects trying to solve for this problem. But with that many projects, you kind of get into the same problem of which one am I going to stick to? Which one am I going to use? Now I've got so many open source versions of the same thing. We're not really getting much depth because we're repeating a lot of the same effort. And it's hard to hedge my bets on which one's going to be the next one to really be adopted as the industry standard. So there was a big concerted effort to take the two biggest projects at the time, Open Census and Open Tracing, and merging that into what we now know as Open Telemetry. So this is really fast become the industry standard, really widely adopted. The traction on this is incredible, and it sits within Cloud Native Computing Foundation (CNCF's) project. And it's the second biggest project behind Kubernetes, which so it's in the right home. Now, thankfully, uh, every time I talk about standards, it reminds me of this comic. But thankfully, we didn't go from 27 to 28. We actually went to one. So it's unlike XKCD in this case. So what does it give us? Essentially, it's giving us, and it's really focused on the collection, the processing, and the transmitting of telemetry data from our digital environments. So it gives us APIs, libraries, agents, binaries to capture, process, and send all that information to wherever it needs to go. Some of the components that it comes with, a couple of key ones I'm going to call out here is that it comes with semantic conventions and protocols. A big one is those conventions, right? So I can tell you now, especially within even a single organization, having things called the same, having data normalization, having things called the same thing across your environment, let alone, between teams, between technology stacks, between runtimes. This can be a lot of effort. It introduces a lot of technical debt, ends up being a big barrier between reusability, between observability assets, and organizational wide insights. So this is going to be a key one here, and OpenTelemetry does a lot of heavy lifting when it comes to at least providing a solid foundation for a convention. You get the binary that handles how we collect and receive that data, and all the various libraries for application instrumentation, support there for metrics, traces, and logs, and it provides coverage for mobile and browser front-end applications as well. Now, if we think about what I normally would see in an organization is over time, different projects come along, and that project will find something that meets their needs, and they'll set it up so that they've got their insights going to somewhere that they can leverage. Team A comes along, or team one, team two, team three. Each of them will have different needs. Each of them will stand up something specific to what their needs are. But before you know it, you've really got a situation that looks a lot like this, right? I've got now within an org, I've got 7 different ways of collecting data across my systems. It's going into 7 different data stores. All of a sudden now, I can't really correlate anything from across any of these easily. It's got to be very manual. And if I want to apply any organizational standards, processes, workflows, if I want to say, hey, as a business, we want to look at X, Y, Z sort of dimension across our data. I want to enforce a ABC standard, then I've got to figure out how to do that 7 different ways. And then I've got to maintain and manage that 7 different ways. So it becomes a very big problem. Anything that team one has done is not reusable across team two's 3, 4, 5, 6, 7, etc. So you're not really getting there really the foundation to drive a lot of innovation and depth, because again, we're repeating a lot of the same effort across these 7 different methodologies. So what OpenTelemetry helps us do is really standardize and centralize how we collect all that data. We've got a single data pipeline that can handle the needs for every single team, and we can easily now manage that into where we want to send that data. Now, I've been a bit cheeky here and I've put Splunk Observability Cloud, but the beauty of OpenTelemetry is that there's a plethora of exporters of where you want to send that data. If it doesn't exist, it's highly extensible. You create your own, and that's very easy to do. And you can send that data to where it needs to go. So, realistically, any endpoint you need it to go, it can be configured to go there. Now, you can imagine if I want to make a change and say, hey, actually, we want to look at our data by tenant ID, I can easily inject that and have it applied to all my data sets, for example. I don't have to do that multiple times over and over and over again. Even from a safety net perspective, you might be worried about PII in a particular data feed. I can set up some rules, again, as a bit of a safety net to as a bit of a catch-all. And I only need to do it once, and it will persist across even the new projects that come on board. So 8, 9, 10, etc. Some other benefits of OpenTelemetry, I speak highly about it. We're very passionate here about it at Splunk as well, is that it's a great way to avoid vendor lock-in of how we collect data, right? So it really commoditizes that data. No longer are you baked in from a proprietary vendor perspective. It's highly extensible. So the needs of each team are going to be quite different. Each application, each environment, each team. It gives you a lot of flexibility there on what you want to collect and how you want to collect it. So they don't need to deviate and take on a very bespoke proprietary piece of toolkit. It's easy to set up. It doesn't need constant maintenance and hammering away at it. You just sort of set it up and it's will stay in place. It can operate at really large scale. Thankfully, we partner with some of the largest digital environments in the world, and the scale of which that they're running OpenTelemetry is incredible. And it was really built from the ground up to be highly efficient and handle very high throughput. And the community, as I mentioned, right, it's fast become the industry standard. It's fast become the community standard. So there's so many users and practitioners out there really passionate about the project and really contributing some amazing code to building out this amazing breadth within the IP. So I'd highly encourage you to check out the project as well. And if you're interested, please feel free to start contributing. The more the merrier. Now, one last thing about OpenTelemetry is that it's also a great way, a great first stepping stone in building out your observability practice. So I get to ask this as well a lot. Where do I start if I want to start building out an observability practice from scratch? It also is just a great foundation. So going native metrics, adopting an OTel standard, and then from there, you can start to build out end-to-end visibility across your key workflows. You can start to also fold in your organizational processes and workflows as well, all the way through to, how do I foster more innovation, velocity, and start to shift left with my development methodology as well. So it's a great foundation for all of that. Okay. Next feature within the platform that I wanted to run you through today is metrics pipeline management. And what metrics pipeline management allows for is in-product aggregation, filtering, and routing of your data. So if I'm sending something in and it's really noisy, I've accidentally added a dimension there that is some sort of ID, and it's blown out my cardinality. It gives me an easy way within the tool, within the platform, to aggregate that out and just keep what I need. You can imagine as we move into a self-service model, the idea here is to allow more flexibility, but we still want some controls to make sure that things aren't getting blown out, right? So with that, development teams are more freely able to pull in what they need. If something has gone wrong, we can easily identify that, hey, this metric, the cardinality is way too high. It's blowing out our usage and our costs. Within the product, we can drop it. That also affords time for the development team to go back and fix it in code. Or if it's not feasible to do it in code, we can rely on the platform to keep that aggregation in place. Beyond just being a cost control mechanism, it also allows us to create additional insights. Well, we might want to do some aggregates to speed up some of our insights that we don't have to then do some computation later. So there's another element to it as well, but as a first port of call, it's a great way to help with cost management. If you think about how that data is coming in, it all comes through the front door. Using metrics pipeline management, we can either do some aggregation, filtering, routing, and if we need to, we can also send things into an archive storage. So if we don't want to drop it, we do want it there as a just in case. There's an archive tier available as well. It's very cheap storage. You can send the data there. If and when you need it, you can rehydrate it back into the real-time tier so that it's not gone completely. It gives you another layer of if there's some uncertainty, gives you another layer of, let's put it in that tier and we can get to it if and when we need it.
You can also get up to reduce by almost 90% of your costs with by archiving your metrics.
Yeah, it's a 10 to 1 ratio. So when I say cheap storage, it's very cheap. Okay, another key one here when we think about moving to especially self-service model is having the right roles and permissions in place. So of course, role and user management. Now, there's a number of predefined roles that you can provision to users within the team, making sure that whether the administrators power just view access, um, and even down to just sort of billing access as well, if you've got people that need to see billing information. So really, it's going to be key to make sure that people have just enough permissions as what they need to do their job. Don't make everyone admin, and use these out of the box groupings to provision accordingly. Now, to make this even easier, if you are an existing Splunk Cloud customer, what's great is you can use your existing RBAC roles and permissions and sign on and so on and so forth to then manage the access into Observability Cloud. So Observability Cloud can hook into your existing Splunk Cloud stack as its identity provider, and those roles and permissions can be managed there. So you only have to do it in one central place, and then your entire Splunk portfolio has RBAC managed for you. So really easy to set up. If you've got any questions on this as well, I think we've got some links in the documentation. If not, reach out to us and we're happy to provide you with additional info on how to get this set up. Okay, observability as code, really key one. Joanna's already touched on this one, something I'm also really passionate about. So, well, the first thing we need to start thinking about is Ollie as code, observability as code. And one of the reasons is we start to move to source control. This gives us a lot of ways to start programmatically dealing with what we're pulling in, what we're changing, and building out also a lot of checks and balances and guardrails into how we go about uh, managing our observability and monitoring content, as well as it's a foundational to having that high velocity and agile sort of workflow that we're going to expect from a self-service model. You can also imagine, right, what's going to be key if you are, say, the team that's responsible for owning the observability platform as a whole, and you're going to be offering self-service to your internal customers. It's going to be great to have a rollback option, a known state of where things are across the organization so that you can easily manage changes, roll back, and audit and identify, give you a lot more governance as to what's going in. So when it comes to as code, there's an API available for every single operation within Splunk Observability. And we've got a Terraform provider available. Well, I think we've got a link to this as well toward the end of the deck that has extensive coverage of all the key functionality within Splunk Observability Cloud. So feel free to have a look at those. Those are going to be great ways to start moving into an as code fashion. There's also really granular token provisioning and controls. So I'd highly recommend to think about what's the right level of segmentation you want to do when it comes to ingest. This can be a great safety net again to say, hey, you know what? Something's gone wrong with a particular token. The ingest has gone through the roof. There's a bug. Something's happened, right? So what's the kind of break in case of emergency? I can disable a particular token and protect the rest of the environment without having everything sort of go ha without having the costs and the data sort of explode for everybody. So think of that right level of segmentation. Those tokens are a great way of controlling and being a great sort of break in case of emergency button. And not only does it give us that great safety net for what's coming through the front gate, it also is a great measure of usage. So we can look at what's coming through at that token level. And if we provision that to, as a team, by a business unit, by a service, by an application, whatever that right level of granularity is, we can then also measure that usage and what data is coming in per token. Also acts as a great foundation for a chargeback or a showback model as well. Now, one other key thing is if anyone's like me and you've put together a query and then a month later you've looked at it and you've wondered what the hell's going on, you can imagine, right? Source control is a great way to keep track of what you're changing, why you're changing it, and just having comments attached to all the assets is really key and critical. Let alone 3 years later when someone's gone back to look at a dashboard and why it exists and what it's trying to do, and there's no one left to explain what it's doing. Um, so yeah, really important. Source control acts as another great way of providing that commentary, that documentation on what we're putting into the platform. I mentioned some of those controls there, so you can take a couple of approaches. I can use those tokens to just look at the usage and view and implement some sort of showback, chargeback. If you're concerned and you want to set some hard limits, you can also do that to make sure that the teams aren't going above their allotted capacity. So really easy to set, and then it's sort of self-managed within the platform. Teamwork makes the dream work, which is not really a feature, but it is important. Now we have the concept of teams within Splunk Observability. This is a great way to group individual users into their respective teams. You might actually have this sort of correlate to the same sort of granularity you have for your tokens. But either way, wherever you've got users that need to share a lot of the same assets, grouping them into the right team gives them a single landing page where you can group together all the relevant assets for that particular team. So I've got all the dashboards that we care about. I've got all of our alerts, all of our detectors, so I don't have to worry about going through every single dashboard chart alert to wonder, is it relevant to me and my team? So a single landing page, as soon as I log in, sends me here, everything's available to me that's relevant to us. Now, of course, I can break away from this and see all the assets, but at least it gives me a landing page for things that are most relevant to me as a first port of call. You can also elect the team captain. I know that can be daunting, but you can elect the team captain, or your administrators can handle sort of who is managing those teams. But really easy to set basically who can be added to what team, what they can do, who can pin things, who can remove things. So team control and access in the spirit of assigning the right roles and permissions is also gives you a lot of flexibility. Another key one is I can tell you right now, a pet peeve of mine is when you've got 85 teams within an organization, and then all of a sudden you've got 85 versions of the same dashboard, but all of them hard coded to that team's assets. Uh, it introduces a lot of technical debt, right? If something changes with the underlying data, you want to change some of the logic, you want to tweak something, or you want to just change some thresholds. You've now got to do that 85 times across the board, and who knows how many other rogue versions of that dashboard have been created elsewhere. A key concept we have within Splunk Observability is being able to mirror dashboards. What this means is I can have a central dashboard, right? In this case, we think about Kubernetes. You can imagine though, a lot of people are using the Kubernetes infrastructure, right? So I want my own view. I don't want to see potentially everything every single time. So what I can do is I can create a mirror of a central dashboard and pre-fill the filtering specific to me and my team, right? So I might just want to look at team A's workloads within this particular cluster. I can set that as a filter, save it as a mirror, and then pin that to my team dashboard. So when I go to this dashboard, I'm seeing what's relevant to me and my team, and I don't have to worry about creating a cloned copy and managing that separately, right? So now when the underlying dashboard gets updated, managed, and maintained, I inherit that, and my mirror still reflects the right filtering into the updated version of the base dashboard. If you haven't been able to tell, I've been watching a lot of Lord of the Rings lately, so that might be seeping through into my memes. I make no apologies. And the last one here I wanted to touch on is data usage visibility. Again, this is going to be a key thing here when you are, especially the team that's responsible for managing observability as a whole. I know it can be very daunting to open up those floodgates, allow a lot of flexibility for end users to start making a lot of changes in a more agile way, right? So you relinquish a lot of that control, but you want to still make sure that you've got the right guardrails in place to protect what is essentially an enterprise-wide service. So we provide a lot of transparency into data usage, right? Across the different capabilities, you can get a very granular view of what's happening across, usage, what's coming in, what's happening with any of the system limits, soft limits, hard limits, how much are people using, what are they using, all these sorts of things. Down to even that soon, we have metrics usage analytics. Now, this gives us a great way of understanding all the metrics coming into the platform and the amount of usage that it's contributing to. You can imagine that if we do have a dimension there that has really noisy or really high cardinality, this gives us a great way of finding out which metrics are contributing to the biggest amounts of usage, their exact toll that they're having when it comes to cardinality. And really importantly, it also tells us which metrics are even being used, right? If it's not being used across any charts or detectors, there's probably a good chance that we don't need it. So if you're seeing really high MTS and it's got zero utility, it could be a first great candidate to A, tell the development teams prune it at source. But importantly, all the metrics that we're seeing on this view, we can then easily navigate to metrics pipeline management we mentioned earlier and do it within the tool as well. So we remove that dependency on development teams fixing things at source, right? So it buys us a lot of that time so that until it's fixed there, we can use the platform to manage again those costs and controls so that we're not blowing out in the meantime. Now, this gives us a lot of transparency, right? So this really turns the transparency up to 11. We can see everything coming through. We can do a breakdown. We can have a look at all the dimensions and what's happening. We can attribute all these things to various teams. Um, Importantly, it's a great way to manage and maintain what we're pulling through the front door throughout our entire metrics lifecycle. So it's coming out very shortly. It's going to be available first in US 0 and US 1, with the rest of the world to follow. I don't have the exact timeline, but check out LinkedIn and the Splunk Observability homepage, and we'll have updates there. But really exciting. US 0, US 1 coming up first, and the rest short to follow after. Now, you might be asking me, these are all great. How do I start doing any of this stuff? And that's a very valid question. So how to start implementing these. Now, look, you can do these in any number of, you know, you can go through any order you like. This is not to say that this is for everybody, but one that might at least work for a lot of people. As I mentioned earlier, right, adopting OpenTelemetry is just a great foundation across the board. So what I would recommend is taking that on first, because that's going to do a lot of the heavy lifting in terms of convention standards, as well as all the assets, binaries, technology, APIs you're going to need to implement a lot of stuff moving forward. Uh, Really, what you should be thinking about is adopting those conventions, and you're going to need to eventually expand it to meet specific needs for your business. So make sure that as you're doing that, as you're expanding, you're documenting that centrally so that we're not now creating three versions of the same thing, right? So you want to set it once within the organization, extend what's there from OpenTelemetry, but have everyone adopt and follow the same convention. So we can maintain that cross-organizational in analytics, insights, and benefits. Really important. So use RBAC to make sure that users have the right permissions. Again, use Splunk Cloud there to, if you've already got it, to help you manage and maintain those. Get those teams defined, add your users, start compiling all the important things relevant to each particular team into those dashboards. And again, add mirrors. Don't go off creating 100 different clones of the same thing. you want to start to move to that as code approach, right? So start using source control, start using CI/CD. If your monitoring teams aren't familiar with Git, run them on a crash course. It's all going to be very important. And what you want to do is you don't want to restrict UI content creation either, but encourage, because a lot of people think visually, so you don't have to be really strict on, don't do anything through the UI, but encourage them to push that back into code uh, as they build it and they're happy with what they've built out, so that it can still be managed and tracked within source control. All right, I touched on this earlier. Think about the right granularity for those tokens, right? Is it at the team level? Is it at the business unit level? Is it at the application level? What's the right level for you to have view visibility on usage, as well as that break in case of emergency button to say, hey, if I need to turn something off, what's my blast radius for what I want to sort of rip the band-aid off? When it comes to how we're getting that data in, not only do we want the right granularity for tokens, but automating how we're provisioning those so teams can get access to onboarding easily. And again, make sure that those rules and permissions and the granularity is reflected in how those tokens are provisioned and allocated. Think about the right level of metadata, all right? Especially as if you are sort of managing observability for those end users, and you might be the tool that's providing that as a service. It's going to be important to think about the metadata, and again, setting the right naming standards and conventions for this metadata. So the metadata will be useful for things like showback, chargeback. We might put in, say, the team name or the business unit name. We might want to start thinking about, do we want to add support group information to our telemetry data? Because this could be useful for if and when things need to go to support teams, if there's incidents. Maybe for content isolation, right? We think about those mirrors. What sort of filtering do we want to do? Do we want to have team, dev, whatever sort of filtering? So adding that in as metadata could make our life a lot easier for how we create mirrors. Even things like creating workflow logic within our application stack. So creating workflow tags, maybe customer segments you might want to know by region, by zone, by tenants. So even moving into some of the more business analytics or deeper analytics from our technical troubleshooting, great time to also start thinking about what dimensions we're going to need within our telemetry. And then even further, you might want to maybe you do this a bit later down the track, but thinking about also org level insights, right? So maybe I put in a project ID, a particular initiative, release, a particular business unit, so I can start to track things like, release on release, what's the benefit we're getting, or which development team has the highest velocity, all these sorts of things, we can start to get a view on that as well. You want to start to develop a lot of integration and content templates, right? So create a template to say, hey, if you're going to onboard a particular application, this is what it looks like. If you're going to be tracking service health metrics, or we're looking at visibility on a particular KPI for the business, create a template so the teams can easily take that on board. They don't have to really start from scratch. So not only does that provide a lot more velocity, but also allows less opportunity for deviation, right? There's already a standard there. There's already a great sort of stepping stone foundation. I can build on top of that. Now, as teams enrich this, especially if we're thinking as code, um, everyone can benefit from this, right? So we can start to build out and iterate on what already exists rather than everyone sort of working in silos and adding enhancements sort of in isolation. And that last one there, I kind of touched on this a few times, which is setting those org level safety nets, right? So adding token limits, creating default rules in metrics pipeline management. So you might be concerned that maybe someone's going to pull through, for example, GUIDs or something as a dimension. So you can set a rule preemptively to make sure that if that comes through by accident, you don't even have to wait for an alert to go off. It's there just as a safety net within CI/CD, right? Setting gates to make sure that the standards, the rules, the expectations, the mandates that you have as a team are being met, and you can fail builds. Another great benefit of having things go through as code, and as well, right? Create OpenTelemetry processes to do some of that work for you. You might want to do some aggregation, filtering, redaction, whatever it may be. You can also do that within the OpenTelemetry binary. So there's a lot there to get started with. And again, this is just the tip of the iceberg. So please feel free to reach out to any of us for more information on any of this. and maybe where you can take it to further from here. So with Splunk and all the tools and features and functions we've mentioned, it really does give you a great foundation to give the teams the observability experience that they deserve. Now, we did mention that there's a whole bunch of resources available. So we'll make sure that these slides are available to you. You can go through. There's a whole raft of documentation, assets, pages, blogs, videos, and reports. So please feel free to have a look at all of these. And again, if there's anything that we don't have on here for you, please feel free to ask in the Q&A or reach out to us offline as well. So without further ado, thank you so much for listening to us talk to you about self-service observability. And now time for some Q&A. So please, if you have any questions, feel free to fire them through now.